Chapter 4 Force and Motion. Samples. 4 identical blocks are connected through light curves along a straight line on a horizontal frictionless table, as shown in the figure. Suppose the maximum force each row can stand for is 20 Newton. What is the minimum horizontal force F acting on the block A should be applied in order to break all ropes? We look at this situation. A, B, C, D moves together with the same acceleration. So F equal to 4ma. We use the free body diagram, we will find TC equal to ma. And A is F over 4m. So we put A inside, we get the T3 equal to a quarter of F. For the same reason, we look at CD together. T2 equals 2m, A is half F. And T1 is 3/4 of F. We check T3 is the smallest. So if the T3 reaches 20 Newton break, T2, T1 will break too. So when F larger than 4D, the D is 20 Newton, 80, then T3 is 20 Newton, is broke. T2 is 40 Newton, is broke. T1 is 60 Newton, broke. That's the answer. F larger than 40, 80 Newton. Sample. A 100 kilogram crate is pushed at a constant speed up a frictionless ramp at a 30 degree to the horizontal, as shown in the figure. Question A. What horizontal force is required? B. What force is exerted on the crate by the ramp? In this question, we have to notice that the crates move up at constant speed. What does this mean? This means it does not have an acceleration. What this means, by Newton's second law, this means the sigma F acting on this crate is 0. That's the physics. Okay. Once you get this physics, you know, as we check how many forces acting on this crate. First is the normal force from the ramp. Second, the gravitational force from the Earth, and applied force F. So this crate moves up at constant speed under the three forces. The sum of these three forces must be 0. Let me take the frame. X is along the crate up. This is Y. So we write the component along X direction. How many? Normal force does not have component along X direction. F does. So we have sigma Fx equal to 0. F has component along X direction, which is this angle, 30 degree, which is F cosine 30 degree. And gravitational force has component along X direction. This one is mg sine 30 degree. So we write it F cosine 30 degree minus mg sine degree equals 0. Now let's look at sigma Fy equals to 0. Sigma Fy is normal is along X positive. F has a component along x direction, which is negative, which is equal to F sine 30 degree. And a gravitational force has a component along y direction, which is negative, equals mg cosine 30 degree. So we'll put them in, we get n minus F sine 30 degree minus mg cosine 30 degree equals 0. So two equation, two unknown, F and N. This is a junior high school math, so I don't do it. I just give you the answer. Sample. A block of mass M1 3.7 kilogram on a frictionless inclined plane at a 30 degree to the horizontal is connected by a light core over a pulley to a second block of mass M2 2.3 kilogram being hung vertically. The pulley is light and frictionless. Question 8. What is the accelerations of the blocks? B. What is the tension in the core? The first question we face is whether M1 moved upward or downward along the plane. We don't know for the time being. I just assume it's going down with acceleration 8. Why? No reason. I have two choices. I suppose it's going up or I suppose it's going down. Both are okay. In my case, I would like to choose it downward. Let's see how they move. We look at M1. How many forces acting on it? We take the reference x down along the inclined plane. T1 from the rope. M1g from the earth. Normal force from the plane. A1 accelerate downwards under the three forces. So we write it. M1g sine theta, sine 30 degree along the x direction, minus t equal to M1a. We look at this one. This t is the same t. A moved down, this must going up. So we see t minus m2g equal to m2a. This a are the same a as a. It's going down, it's going up. This t is the same t as this one. This is how they react each other. When we write this equation, we don't have to consider others because they share the same t and a. With these two equations, two unknown for a. It's very simple, junior high school. Math, I don't do it. I just give you the answer. The answer A is minus 0.74 meter per second per second. What does this mean? This means the real movement of M1 is going up, the minus direction as I assume. Okay, it's right collection. Sample. Two identical blocks of A and B are held by a light core and a light spring in two different configurations as shown in the figure. Find the acceleration of blocks A and B at the moment when the core is burned off in each case. Let's assume the direction y is upward. We look at this. For the block A, it was F from the spring acting on it upward, T from the rope downward, and gravitational force mg. So we write this equation is F minus mg minus T equal to MAA equal to 0 at rest. For block B, it was a same T from the chord on opposite direction and mg, so we have T minus mg equal to MAB that equal to 0. Now, let's burn off the chord. The T instantly becomes 0. At the start case, from these two equations, we find that T equal to mg. F minus mg equal to 0, F equal to 2mg. So when we burn off the chord, the T instant equal to 0, but F does not have time to change. Okay, so we look at this one. F minus mg 0 equal to MA. In this A, because F equal to 2mg, 2mg minus mg equal to mg. So AA at this instant, AA is equal to G. In our direction, AA is going up at this moment. For block B, you see T equal to 0 instantly minus mg equal to MAA at this time. So AB at this moment equal to minus G is going down. Remember, at the moment when the chord was brought off, A has acceleration G up, B have acceleration G down. At this time, they don't have speed at all. The speed start to change. Look at this situation. Look at block A. You have T from the core, F from the spring, and mg from the earth. So we see T minus mg minus F equal to MAA equal to 0. Look at B. You have same F minus mg equal to MAA and B. Now, we burn off the chord. T instantly becomes 0. Before we burn off, F equal to mg. T minus mg equal to 0, T equals to 2mg. It's different from this case. And we burn off the chord, T becomes 0 instantly. So this minus mg minus 2mg. So AA equal to minus 2g going down. And B, look at this equation. B will not be affected by T. So AB will keep the same. This is mg, so AB is 0. Sample. Blocks B of mass MA, B 10 kilogram, and A of mass MA 20 kilogram are both on a frictionless horizontal plane and are connected with a light spring, as shown in the figure. When a horizontal force F of 200 Newton is applied to the block A, the acceleration of the block B is AB equals 1.20 meter per second. Find the acceleration of block A. Now, in this case, the point is the light spring. The light spring can vibrate. So the acceleration A is different from acceleration B. When F of 200 Newton apply, we look at MA. How many forces acting on it? Beside F, we also have a T from the spring. How much? We don't know. Okay, so the equation is F minus T equal to MAAA. This AA is what we are asked to find. We don't know T. We can find a T, we can find an AA. Then look at block B. Horizontally, it was exerted only by the spring, light spring. This force is also T. Why? Because this spring is light. Okay, they are the same. So T equal to MB AB. We know AB, we know MB, we get T. We get T put inside, we get A. It's a very simple one. Okay, I'll give you the answer. The AA is 9.4 meter per second per second. The AB is only 1.20 meter per second per second. It's quite different. Sample. A force F is pulling a pulley vertically upward. Two objects, M1, 1.0 kilogram, and M2, 2.0 kilogram, are connected by a light rope over the pulley. The object M2 is kept on ground. Question A. Draw the free body diagrams of the pulley and the two objects respectively. B. What is the maximum force F while keeping M2 on ground? First, let me draw the free body diagram for pulley. Three forces acting on it. T, the tension in the core, they are the same. And F. Since the pulley is light, so we can see from this free body diagram, F equals 2T. Right. Now the M1. How many forces acting on M1? Tension T from the rope, gravitational force M1G from the earth, and it accelerates up. So we have M1 is T, M1G, and accelerates A1 up. For M2, it exerts tension T from the rope and normal force from earth, from ground. It rests on the earth. So we have T plus normal force from earth and minus gravitational force M2G equals 0 because it's at rest. Now we write this equation from this one. T minus M1G equal to M1 A1. Look this one. T plus N minus M2G equal to 0. Why? Because this is at rest on ground. We look at this equation. We see. We didn't see F. And the question is F. We know F equal to 2T. We find a T, we find F. Yeah. Look at this one. In this case, T equals M2G minus N. A T related to M. N is the reaction between the block 2 and the earth. If N equal to 0, that means they separate. They don't have interact between them. Okay. So when we pulling down with F increase and increase, T increase, and N decrease. When N just approaches 0, that means this one is block 2 is going to leave the ground. So T maximum is N equal to 0. You get an M2G. They just separate. So T is maximum, F is maximum. F equal to 2 maximum. So equal to 2M2G. 2M2G. We put number inside, we get 39.